Hello, everyone, and welcome. This is Adel Tahir, and I'll be the moderator of today's webinar titled Introduction to Advanced Mud School, presented by our instructor, Engineer Abdulaziz Jabr. Engineer Abdulaziz has a bachelor degree in petroleum engineering from Suez University in 2010. He worked as a mud engineer in EMEC company in KSA from 2011-2015. He also worked as a drilling supervisor in Khalda Petroleum Company in Egypt from 2015 to 2022. He works now as a drilling instructor for drilling engineering topics like mud engineering, stack pipe and fishing, well control, and workover and completion. He also has a channel on YouTube under the name of Abdulaziz Jabr to deliver drilling engineering courses. Before we start our session, I'll just make a small presentation about OPA services and plan. This Saturday, we will have a live course certified IADC Advanced Mud School that will be presented by the same instructor of today's webinar, Engineer Abdulaziz Jabr. It's a 2 week course. It starts on next Saturday. The course price without certificate is $275 and the certificate price $250. This makes a total of $525 only for the 2 week course. You can also scan this QR code to register, and I will also send the link on the chat after I finish my presentation. Here in OPA Energy, we have delivered more than 50 live courses, which are now available as recording sales in different petroleum topics like reservoir engineering, rig and rigless operations, production technology, G&G, data analytics and safety, and so on. You can scan this QR code to register in our recorded courses. Here's one of our best services, which is mentorship program. It's a one-to-one mentoring sessions by highly experienced mentors. It's like a tailored program based on the mentee's needs. You can request explain the know-how of a software, guiding on personal data, professional guiding for PhD and master, helping undergrad students in their projects. We have completed more than 50 mentorship program with more than 950 learning hours, and the mentees were from more than 10 different countries. You can also scan this QR code to register. Here's a glance of our website, opacourses.com, where you can access everything we have talked about, like enrolling in live course, enrolling in recorded course, enroll in our free webinars, apply for a mentorship program, or even apply for internship. You can access everything through our website, so make sure you pay it a visit. So how to be an OPA ambassador? There are 2 tracks. Take one or more courses or take a mentorship program. So what will you get from being an OPA ambassador? You will get discounts on all courses in the future and group discounts when you get your friends with you. Finally, for the webinar certificate, it will be generated automatically on our website on the webinar page tomorrow. So just make sure that you have joined this Zoom session through website to get the certificate. Thank you for listening, and now it's time for our session. Engineer Abdulaziz, you can start your presentation now.
Okay, everyone is hearing me now, right?
Yes, we can hear you.
Okay. Okay, good afternoon. Thank you very much, Adil, for this introduction. Thank you, guys. Today, inshallah, we will start our course. Not course, this is our introduction to the course that, inshallah, we will deliver from the next Saturday. It will be plus minus 10 days, 9 days of working, and the last day will be the assessment, inshallah. Actually, this is the advanced mud school. What is the advanced mud school and why we take it and why it is required? Actually, the advanced mud school, it's we take the basic mud school for the non mud engineers. Any mud engineer, anyone who needs to work as a mud engineer or even drilling engineer or whatever, we give him the course at first of basic mud engineer. This is the first. Then after this I give him some information about chemistry, information about reactions, information about shale, about the rig, about everything. But the advanced mud school is especially it's specialized for mud engineers. Okay, it's specialized for mud engineers because you take more information about the drilling problems, about other issues. But let's talk about the content of the advanced mud school that will be in the course, inshallah. First of all, this is introduction. Actually, Mr. Adil had already introduced me to you, and just in brief, I have worked. I was graduated from Sewage University in 2010. Then I worked as a mud engineer for almost 4 years in Saudi Aramco, in EMEC in Saudi Aramco. Then I work as a drilling and work over supervisor in Khalda from 2015 until now. I am accredited drilling instructor in mud engineering, stack pipe fishing, well control, work over completion, stick line, and drilling problems. I already all the courses that I am accredited, I have already put on my YouTube channel Abdulaziz Gab. So at any time, if you need any course, you can go through the channel and go to the playlist. You will find everything or every course from these courses. Now, actually, I'm working in other courses like work over. I'm planning. I'm making something. It's just from 1 year. I started to prepare for it from 1 year and it needs about 2 or 1 or 2 months more to release the course on my YouTube. So inshallah, it will be outstanding, يعني, because I get a lot of information from all over the world, from different areas, from different policies to deal with work over with live wells. So inshallah, this is our next course I will put in my channel. But as per this webinar, we will talk, inshallah, about the Advanced Mode School. What we will talk about the Advanced Mode School in the course, we will take introduction generally, introduction about the rig, about some informations we will take from the basic mode school, like chemistry, like the completion types, يعني, like also pH, alkalinity, all these issues, يعني, okay? Mud parameters and functions. We will talk about them in. We were already talked about them in the basic mud school, but we will go deeply in these functions and mud parameters, especially for the hydraulics and rheology, rheology and hydraulics exactly. And we will talk in details. What is the yield point? What's the gel strength? What's the difference between progressive and fragile gel? What is the effect of each one of them? We will talk about advanced mud calculations. For example, you have oil-based mud and you need to change their oil-water ratio. You need to change oil-water ratio from 2, and from 70-30 up to 80-20 or whatever. How many diesel you will add? Also, this is change in oil water ratio. Osmotic pressure calculations. For example, you are drilling in the shale, different salinity. What will be the effect of the osmotic pressure, and how much it will affect, and what about the pressure, the mud weight that you need to overcome this issue, يعني, or how to deal with it. All this we will talk about. Rheology and hydraulics. Actually, rheology, yield point, gel strength, viscosity, low shear yield, especially in directional and in horizontal wells. Also, we will talk about hydraulics and hydraulics. We will talk about everything in hydraulics until we reach to the hole cleaning and reach to the bit nozzle selection for good hole cleaning and for also bit hydraulics optimization. We will talk about hole cleaning and the cutting transportation and what are the mechanisms of hole cleaning and the different issues to make hole cleaning in drilling vertical, drilling directional, drilling horizontal. Also the solid analysis and the solid control equipment theory and how to make good evaluation for your tools in the solid control. This is very important lessons. So we will talk about all this, inshallah. Actually, and each session will be from 2 to 3 hours. So actually, this is very important course. Yani, I recommend from all of you to attend it. Yani, this will be very very important. Yeah. Wellbore stability and the shale problems, stuck pipe diagnosis, and freeing techniques. We will talk about all this from A to Z, types of stacks, like differential, like back off, different types of back off. Also, we will talk about the whole geometry, about the diagnosis for each one, about also the first action to take, about also the remedy by using different ways. Yani. Shale problems and bed bullying. We will talk about the shale and the problems. Also about the shale inhibition. We will talk all about this. Loss of circulation and its planning strategy and preventing loss of circulation from A to Z until you cure all the losses. Okay. Completion fluid and corrosion control. We will talk about the compression fluid parameters and its viscosity, its pH, TCT, true crystallization temperature, or true crystalline temperature. We will talk about the solid content. We will filtration by NTU. What's the difference between NTU? If you are running hole with, for example, with the screens, what is the PST test for screen testing? You have to know all this, by the way. We will talk about all this. Advanced fluid system like the glycol mud, like the silicate mud, oil-based mud, and the high-performance mud. You will know exactly the silicate, the glycol, and the BHBA, by the way, sometimes, and how to calculate each one of them, how to calculate the glycol percentage, how to calculate the silicate percentage, and what is the test you have to do. What are the reagents required to do these tests? All this will be discussed. Formation damage. What is the formation damage? What is its effect on the productivity index? Why we have to take care about the material, each material we are bombing in the hole. This is very critical. Okay. What are the criteria of non-damaging fluid system? For example, like formate mud, like high performance mud, like any mud and any system like Flow Pro or whatever Pro, all the Pro series. We will talk at least for one of them. Yani, by the way, what are their criteria for non-damaging? Yani, what is the hog wash? What is the best practices for displacement to displace from mud to compression, for example? We will discuss all this. Basics of full control, because يعني the main issue for the advanced mud school is to discuss the drilling problems. So the first problem is the well control. We will talk about abnormal pressures like artesian wells, like shale, like any a lot of them. يعني. You know already. I give a course in this well control. It's on my channel, but at least you should have the basics, and we will discuss it smoothly يعني. The shut-in procedures, hard shut-in and soft shut-in, gas migration. Also, we will talk about killing methods. The driller method, weight and weight, and also about volumetric, bullheading, all this. Okay, BOB stack and some equipments for the BOB. Also, we will talk about very advanced thing in the advanced mud school. It's called the stress caging techniques. By making the proper PSD for the bridging materials. يعني bridging materials, we need to make PSD, better PSD. So we have to check for stress caging techniques and their BPT. Okay. Basics of directional drilling terminology. What is the inclination? What is the azimuth? What is the vertical section? And also some information in brief about the dogleg severity, about all these things. Yeah, okay. How to initiate mud program? How the mud program is written? Because, for example, the advanced mud school, when you are in the basic mud school, but advanced could be for your supervisor, for your superintendent. So some companies are requesting from mud companies to make proposal for the mud. We need to know how this proposal is done. Okay, all these informations will be discussed in brief in the course starting from next Saturday, inshallah, or Sunday, yeah, depending on the time. Case study. We will take case study. For example, case study for a problem happened uh, in a field and they need to fix it. How they fix it? By using the mud. Because I need you to think exactly what will happen just for any problem by using the mud. Okay, so we will take case study and we will make general revision for sure. And finally, we will make a course assessment for all of you. So today we will take some brief informations about what we will give inshallah, but it's a 10 days course, so it's very long course, but inshallah it's very effective once you take it. Actually 100% your knowledge or your information will change about a lot of things. Introduction, this is a drilling rig. We will talk about the rigs. Yeah. For example, this is the components of the rig: crown block, traveling block, cat line, cat boom line, and hoisting line, drilling line, monkey board, traveling block, top drive, and the mast. Yani we will talk about all this, okay? All this in brief for sure, yeah. Okay? We will talk about the well completion. What is the completion? Actually, the completion, it is the stage between the finishing drilling and to put the well to the production. Yeah. So the completion types. What are the completion? The completion simply means making the well ready to produce oil and gas under controlled pressure and flow rates. Okay. So the most common types of completions that we are dealing with: open hole, if you have good good reservoir or have a good amount of hydrocarbons in the reservoir, so you can produce by running hole with open hole completion. Gun perforated, which is the most common all over the world, by running hole with casing, cemented casing. Then after this, make the perforation by guns, by TCB or wireline or whatever. So you can produce through the perforation. Slotted liners, you will also use the slotted liners while يعني, okay, it's type of completion يعني is slotted liner. And gravel pack liner, if you have a lot of sand production, so you have to make uh, gravel pack as a completion, yeah. Advanced mud calculations, this is number two. What we will talk in advanced mud calculation, we will talk about building up salt mud. For example, salt mud. How can I build the salt mud? What is the volume required from the salt, or what is the weight from the salt and from the water to build up the mud in details? Changing oil-water ratio in oil-based mud, like the examples that we will talk today. Calculations of the salinity in oil-based mud. We will talk about the calculations of the salinity in oil-based mud. and decreasing the solid content. For example, if I need to decrease the solid content by dilution, so I need to decrease the low gravity solids from 6% up to 3%. This will happen by dilution, but I need to know exactly how many barrels of water I should dilute, I should add to change the low gravity solids percentage from 5% or from 6% to 3%. We will talk about it. Solid analysis also we need to talk about it inshallah. Just an example about just one example. This is inverted emulsion oil base mud. The oil water ratio equals oil to water. So the oil fraction is the percentage of oil in decimals from the return to test divided by the total fluid, which is oil and water percentage. Okay, then multiplied by 100%. Water fraction equals 100 minus the oil fraction gives you the water. So the oil to water fractions, for example, 70 to 30 or whatever. This is an example. I need to increase the oil water ratio in oil based mud. For example, this is 500 barrels of oil based mud with density 12 ppg. Its oil water ratio is 60 to 40. So the following results of the retort analysis, the water percentage were 28 milliliter. Oil equals, sorry, equals 42 milli, and solids equals for sure 30 milli. How many diesel barrels are required to change oil water ratio to 70-30 from 60-40 to 70-30? So, and what is the final volume and the final mud weight? And how many barite sacks are required to increase the mud weight again to 12 ppg? Actually, here we assume that we will add diesel. So the water is fixed. This is the same water. Okay, but its percentage will change from 40 to 30. So the water will be the same, but its percentage is different. So we get here the number of total fluid, which is 930.33, minus the old one, which is 42 plus 28. So it gives you 23.33 barrels for each 100 barrel. And we have here 500, so you will multiply all this number by 5. So the number that I need will add also diesel. I will add diesel about 117 barrels of diesel to change from 60-40 to 70-30. Okay. Then after this, I will check about the mud weight, the new mud weight. Once I get the new mud weight, I will check for the barite I need to add. This is as simple as this. After this, inshallah, we will talk about the rheology and the hydraulics. What is the rheology? Actually, the rheology affects the carrying capacity, slip velocity, and annular hydraulics. Sorry for this voice, by the way. Fluid rheology also affects the suspending characteristics of the drilling fluid. We will talk about the fluid. What is the Newtonian fluid? What is the non-Newtonian fluid? And what is the difference between them? Actually, the Newtonian fluid is like the Newton law, which is by Isaac Newton. Every action has response, okay, but in opposite direction. Okay, so here the Newtonian fluid actually is like water. It's a Newtonian fluid, fluid without solids. So it's called Newtonian fluid. But non-Newtonian fluid, like most of the or all of the drilling fluids, is called non-Newtonian because it has it needs at least to get some yield. To get some yield, for example, to start movement or whatever. Yeah. Okay. So we will talk about the non-Newtonian fluid exactly and what are the characteristics, what is the yield point, what is the gel strength, what is the viscosity, what everything. Okay, we will talk about. We will talk about the rheological models. What is the rheological model? Rheological model is a description of the relationship between the shear stress and shear rate. We'll talk about both of them also. We will talk about Bingham plastic model, power law model, and Harshey-Bulkley model. And what is the difference between each one of them? Bingham plastic model, it uses on the high shear area to get the plastic viscosity and yield point. Power law model, it's modification with N and K for the consistency factor and the power law index like N and its effect on the viscosity and in hole cleaning and everything. Harshey-Buckley is a mix or modification between both of those two models. So actually, it's great. Yeah, we will talk about those three in details. We will talk about gel strength and the gel strength. It's attraction between solids under static conditions. We have two types of gel strengths: fragile or flat. Okay, this is when we have 10 minutes and 10 seconds. We don't have gap between them. We have just the readings are nearly to each other. But progressive or elevated, we have great difference between the 10 minutes gel and the 10 seconds gel. Actually, is if the mud is contaminated with solids and also for carbonate contamination. Yeah, okay. As you see here, this is the fragile gel. The readings are between the 10 minutes and 10 seconds, as you see here, is not so big. Yani. It's just a small amount. But as you see, this is a progressive one. As you see, this is critical one. Okay. We will talk about hydraulics. What is the hydraulics? Actually, hydraulics is an operation where the drilling fluid is used to transfer pressure from the surface to the bed, using pressure drop across the bed to enhance the rate of penetration. Part of this energy is used to clean the face of the bed, and the pressures exerted in circulating a well can be calculated using rheological models. So what is the flow regime? What is the flow regime? What is the difference between the turbulent flow and laminar flow and the plug flow and all these types of flow? What is the difference between plug flow, laminar flow, transitional flow, and turbulent flow? And what is the Reynolds number? We will talk about the Reynolds number and how the flow pattern affects the velocity profile in the annulus and how this affects the whole cleaning. Yeah. Okay. This is the Reynolds number. It's the ratio of the fluid's inertia internal forces to its viscous forces. And the Reynolds number. The Reynolds number is based on the following formula. We will talk about all this in details. Also, we will talk about the whole cleaning and its difference between the cleaning or the cutting behavior from the well from 0 to 35 degree, from 35 degree to 60 degree, and also more if we have more than 60 degree. Guidelines for effective hole cleaning are therefore different. So that as you see here, this is the vertical, this is the directional, and this is horizontal. Actually, the directional is the most critical one. Why? Because this cuttings, it's moving while circulation. But once you stop circulation, it makes something is called avalanching. So you have to make good hole cleaning by pumping tandem bells frequently. Okay. That's it, yani, by the way. We will talk about also the inhibition mechanism. What is the inhibition mechanism? Actually, we have the shell, and the shell, it could swell or disperse. Swelling means if you have if you have some problems or osmotic phenomena where the salinity of the water based mud is the salinity of the water with mud يعني is less than the salinity of the shale. So depending on the osmotic phenomena or osmotic pressure, the electrolytes is transferred from the low salinity to the higher salinity, so that it makes the swelling for the shale, and it leads to stuck, by the way. To prevent this, you have to make good inhibition for the shale. Inhibition, we have many mechanisms. Actually, this is a shale cutting, this is a swelling, and this is dispersion. Okay, so the swelling, this is the ideal one. This is swelling, it means increase in volume. Dispersion, it means يعني it's dispersed يعني, okay, dispersed to small pieces يعني. What's the hydration? Hydration may occur because the concentration of cations in the crystalline water in shale is greater than that in the drilling fluid. As a result, water in the drilling fluid will invade the pore spaces between the clay plates and forces them apart, which is known as osmosis phenomenon. Dispersion results from water breaking down the internal structures of the clay lattice. The particles expose new faces that break down further. يعني, okay? Mechanical degradation can also break the drilled solids or make dispersion. So, depending on this, we will make a lot of mechanisms for inhibition. We will talk in details about them. Number one, oil wetting the surface rocks by using oil with mud. Cation exchange by using KCl, for example. We will talk about reducing the pH, and this makes the activity of the shale is less than the required. Okay. Encapsulation polymers by using PHPA. We will talk about it also. We will talk about reducing the fluid loss. What's this? Okay. Okay. We will talk about increasing the chloride content to be matching with the same in the shale in order to avoid any osmosis phenomenon. The precipitates mechanism by using the silicate mud, we will talk in details, and also the salt saturated mud for halides to avoid any problems in the halides يعني, or in the salt domes. Okay. One more thing we will talk about is the solids control equipment. We will talk about the solid control equipment by talking at first about the solids analysis. And after the solids analysis, we will talk about the solid control themselves, like the scalping shakers, like linear shakers, desander, desilter, centrifuge, and also the centrifuge itself applications, bright recovery or not recovery. So this course has tons of information. يعني. So I recommend from all of you actually to attend this course, يعني, by the way. Okay. Solids control philosophy. Solids control philosophy. Here to minimize the volume percentage of solids and to maintain the quality solids consistent with desired drilling fluid properties. Why we try to reduce the solids? Actually, the increasing of the solids increases the filter cake, and this can lead to differential stuck. If you have a small filter cake, for example, if this filter cake width is 240, and if it is 960, here the force required to free the string is about 25,000. Here is about 100,000 pounds. So sometimes you have to damage this filter cake, yeah, by the way. So the decreasing of solids will avoid this problem. Here, types of solids. Actually, the mud solids, plastic viscosity, yield point, and gel strength are all affected by mud solids. These may be divided into two types, like high or low gravity solids. A high gravity solids, this term refers to the weighting material added to a weighted mud to increase the mud density. The ideal weighting agent should have the following properties. High specific gravity, for example, the hematite is 5, specific gravity 5, and for barite is 4.2. Also here it must be chemically inert, يعني it is not يعني reactive, and also it should be low abrasiveness, يعني no abrasion, يعني this is very important. The most commonly used weighting agent is the barite or barium sulfate, as you see. The API specification for barite is specific gravity 4.2 minimum, particle size maximum 3% for more than 47 microns, and minimum 5% more than 44 microns. Other weighting agents commonly used include hematite, which is ferrous oxide, which with gravity 4.9 or 5.3, ilmenite specific gravity 4.8, and calcium carbonate specific gravity 2.6. Hematite is used where mud weights is in excess of 18 to 19 ppg are required, and so on. The calcium carbonate, it's low weighting. Also, it's used to decrease the formation damage and to remove the formation damage where the reservoir must be stimulated by acidizing because it's acid soluble. The calcium carbonate is acid soluble, so it can be used in the reservoir section. The mud solids we have as the second one. This was the high gravity solid. This one, the second one is called low gravity solid. The low gravity solids, it can be desirable or it can commercial يعني, or it is drilled solids يعني drilled solids or commercial solids يعني. All the solids away from high gravity solids is called low gravity solids. But this low gravity solids we have two types. One of them is يعني low gravity solid. One of them is يعني commercial, and one of them is non-commercial bottom. Okay. Low gravity solids comprises all other solids in the mud. The average specific gravity of low gravity solid is usually taken 2.62 or 2.65 solids analysis calculations. Low gravity solids, it can be further subdivided as follows, like desirable or commercial, like for example, bentonite, polymers, to give a lot of functions for the drilling fluid to work properly, and non-desirables like the drilled solids, which is unavoidable. You can't avoid them. Here's the density of the mud additives, all these mud additives, okay? What are the ways to obtain desired fluid properties? By reducing the solids. Number one, dilution. Dilution by يعني mud mainly is composed of solids and base fluid. So if you add more base fluid by dilution, so the percentage of solid will be decreased. The percentage of solids will be decreased. Number two, displacement. Displacement, it's a partial replacement of the fluid. Partial replacement of the fluid. Here, mechanical separation, removal of the drill solids by particle size and density difference. For example, like shell shaker, like centrifuge, like everything. So this is the mechanical separation. Also by settling, using the settling tank and on the slant wall, then dump all the cuttings and the bottom. Here, this is the settling tank and this is the slant bottom. These are the solids that are accumulated here. So you open the dump valve and drop all these solids here. We will talk also about very important thing to deal with the solid control. It's called the D cut point and the particle size. For example, when I say D50 for this API screen, for example, is 74 microns, for example. What is the meaning of D50? What is the meaning of the API? All this will to be talking about, like cut point designation should include the percentage of the stated size removed. Cut points should always be denoted with the letter D, with the subscript indicating the percentage to be removed. So when I say D80 means 80 percentage of this size is removed or is discarded by using this shell shaker or this shaker screen. Without this percentage, no two cut point sizes can be compared. For example, when I say a D50 cut point of 40 microns means 50 percentage of the 40 microns size particles have been removed from the system and 50 percentage has been retained in the mud system. And this is the graph. This is a graph. As you see, this graph here is the particle size, and okay, here this is, for example, D20 percentage solids, D20 percentage solids here. D20 percentage solid is, for example, 25 micron. What I mean here for this screen, this is a screen log plot. As you see, this is the particle to be removed by the screen, and this is the particle size. This is the percentage, and this is the size. So when I say D80 or D90, for example, I say D90 percentage of the solids is removed by, it will remove, for example, 58 micron by this screen. And for 50, it will be 35 micron by this screen. So this is normal, yeah. Okay, we will talk about this. This is a shell shaker, as you know exactly. This is the vibrating assembly. This is the mud and the cutting. This is the boson belly, and this is the flow line, by the way. And here the pool and the pitch, and this is the cutting discharge. Yeah. Okay. Shaker characteristics: it should handle 100% of the circulating volume. It should remove the solids larger than 74 micron. Separation by vibration and straining through the screen, and dependent on shaker installation and configuration. Maximum area of the bowl should be 70 percentage of the pool, okay? Because you have pool and pitch. G-force, because this is very important in removing the cuttings. We will talk about G-force and evaluation of the G-force, by the way. Okay, the stroke in inch multiplied by the RPM square for the motor divided by this constant. Okay, we will talk about the mud gas separator and why we are using during a killing operation. This is very important because it can handle high amount of gases. By the way, here the mud from the flow line is directed to the mud gas separator to remove any large amount of gases encountered while cleaning. Actually, this is not from the flow line, so it should be from the BOB, from the BOB assessment. The removed gas is directed away from the rig, personal to remote location, and is vented and flared. The gas cut mud is pumped to the spray chamber of the atmospheric degasser at high velocity through disc valve. Okay. The mud strikes the inside wall here of the spray chamber with enough force to drive most of the entrapped gas out of the mud. Vacuum degasser, we have vacuum type degasser which separates the gas bubbles from the drilling mud by spreading the gas cut mud into thin layers and then drawing off the gases with a vacuum pump. Vacuum degassers are normally skid mounted and installed on the top of the mud tanks, as you see here. Yeah, okay. We will talk about desander and desalters like hydrocyclones. What is the difference what is the difference here يعني actually as you see this is feed inlet feed it comes tangential to the cone surfaces so here centrifugal forces is generated and the heavier cuttings can drop here there is a vortex here vortex occurs and the heavier cuttings can drop from here while the other mud يعني can go through overflow to the liquid يعني okay overflow to the system and continue actually desander it can remove the cuttings from 74 between 74 and 45 microns desilter from 35 to 15 microns and there is micro cones small cones يعني the difference between desander and silter is the cone size and also their يعني D50 يعني okay here this is the mechanism I have already illustrated no problem okay this is the same يعني I have already centrifuge what is the centrifuge and why we are using the centrifuge actually centrifuge we use the centrifuge as you see here this is conveyor this is the conveyor and the outer barrel and the conveyor and they are rotating with different speeds so the differential speed between both of them will generate the gravity is sorry the centrifugal force so the cuttings with the high density is يعني it comes to the centrifuge to the circumference and then it can be separated while the other mud can go to the system again but here we are dealing with very high RPM يعني very high RPM it can reach to 2600 by the way to remove the low gravity solids okay so the components bowl or drum and conveyor scroll and the gearbox to change between the RPMs يعني here the frame and collecting vessel and also feed inlet and distribution okay principle of operation as I told you here the bowl and the conveyor are rotated at speeds between 1500 and 4000 RPM this rotation develops centrifugal force sufficient to settle solids along the inner surface of the bowl wall the gearbox is used to rotate the conveyor and the bowl at slightly different speeds, slower or faster. Then, okay, so a lot of solids can be discarded. Okay. Also, we will talk about the cutting dryer. Okay, it is the same mechanism, but it has vertical mechanism, يعني up. So this vertical can make drying for the cutting. We will talk about everything in details. Yeah. We will talk about the mechanical agitators and its impeller and how to make maintenance for this agitator, by the way, and the angles of these impeller blades. Yeah. Mud guns, we will talk about also the mud guns, which are the devices usually carry mud from downstream compartments and spray it at high velocity into the upstream compartment to keep solids suspended. We will talk about completion fluids also. Completion fluids, what is a completion fluid? Completion fluid, it's any fluid which is designed and used in the reservoir section of the well. The major goal of the fluid design is to reduce the potential for damage of the reservoir and maximize the volume of oil and gas which can be extracted from the well. We have clear brines or brines. We have also reservoir drill-in fluids that can be used. Benefits, for example, for clear brines completion. Number one, solid free to reduce the formation damage. Number two, the formation compatible salt solution. because if I am using salt saturated or salt mud in the reservoir which has a lot of calcium, so it will make a scale. This scale will make skin factor, and this skin factor will affect the productivity index, and it will make a lot of problem for me, by the way. Actually, initially low density soluble for and chloride solids like KCl, NaCl, CaCl2 up to whatever I need. Routine application like work over Packer fluid or Kell fluid. Also, we have some introduced bromide. We will talk about the bromide salt and its dangerous effect. Bromide salt. This is very important, and also it is very dangerous. So we have to talk about because يعني sometimes in the interview you will be asked, do you before you worked before with viscous brine or with high viscous brine like bromide salt or whatever, because its viscosity is different here. Okay, increase the usable density to 21 ppg. Okay, so here sodium bromide, calcium bromide, zinc bromide, sodium mixture between calcium chloride and bromide. This is reduces the cost. So we will talk about them and their mix and everything. We will talk about the properties, the density of the brine, and how can we calculate the density by measure the density by using tool by using the tool also called hydrometer. Okay? Here the TCT or true crystalline temperature, we will talk about it and its effect and how it affects the brine. We'll talk about the pH for each brine and the solid content and its NTU. We'll talk about turbidity units, NTU, and its meaning, and the viscosity, especially for high weighted brines. Uh, Also, we will talk in the advanced grad school in the problems that we are dealing during drilling, like for example, stuck pipe. What is the stuck? Okay, when the pipe is considered stuck, actually, the pipe is called stuck pipe depending on mechanical properties for the pipe and the rig capabilities. For example, I run in hole with drill pipe, sorry, with drill string, yani, and the drill pipe maximum tension that I can apply is 100, for example, 100 kilopound, for example. So if I need force more than this force to free, okay, I call stuck here. So at this time I have to cut or to make back off and run hole was overshot with drill pipes with higher grade, يعني with higher grade like S135, so I can catch them and free it. Also the rig capabilities. Some rigs don't have high horsepower, so they can't also free the stuck. So the stuck or the pipe is called or is considered stuck regarding the pipe mechanical properties and rig capabilities. Here, sticking mechanism. Number one, induced back off. We will talk about the induced back off and the different types. Mechanical stuck like formation related or wellbore geometry like dog legs and ledges and all these issues. And differential طبعا depending on the high overbalancing. Pipe sticking has mechanisms which will be addressed in terms of causes, warning signs, and prevention and freeing. We will talk about this. Here, the back off and the bridging, as you see, this is the back off, this is the bridging. The difference between both of them, back off, no circulation at all. Bridging, you have limited circulation. Okay, cutting here are very small, but here it's medium to large. So back of small pieces of formation or cement or junk settled around the drill string, preventing circulation with no string movement likely. Bridging here, as you see, this is medium to large pieces of formation, cement or junk settle around the drill string, allowing restricted circulation with little to no string movement. Here the Wilbur geometry mechanism, as you see, sharp changes in hole angle or direction and under gauge hole diameter or increase in the assembly stiffness will not allow passage of the string. Okay, the differential sticking mechanism also, this sticking force generated by the overbalance pressure driving the static drill string into thick filter cake of the permeable formation, which is very critical one, and always the mud engineer was the first one to be blamed blamed for this type of stuff. We will talk also about the loss of circulation. The loss of circulation here, normally mud losses occurs when the hydrostatic pressure exceeds the fracture pressure of the formation. It occurs in weak formation. We will talk about this. High permeability like dolomite or like limestone, unconsolidated sand, natural fractures or faults, all this. Invasion, natural causes like unconsolidated formation, high permeability, limestone formations with vugs, and in depleted sands. We have types of losses, and for sure we will take on details here. What is the seepage losses when it is less than 10 barrel per hour? Partial losses from 10 to 30 barrel per hour. Severe losses from 30 to 100 barrel per hour. The hole will remain full with the pumps off. The total losses more than 100 barrel per hour, more than 100 barrel per hour. The roll will not remain full with the pumps off. Types of lost of circulation material. Types of lost circulation material. Fibrous like fiber, paper, magma, fiber, whatever. Granular like nut plug and G seal and calcium carbonate. Blends like seal, MI seal or whatever. Flakes like mica. In case of complete losses, you have to, and in case of seepage losses or severe losses or whatever, we are bumping LCM. But here I will talk about complete losses. In case we have complete losses, you have to bump several regular LCM bills with high concentration, sometimes it reach to 200 pound per barrel. If still losses persist, so several alternatives will be done like brine hole and make cement plug, make junk squeeze, make cross-linking bills. Sometimes also you run hole with something is called B&A isolation kit. Okay. In case of complete losses, switch to mud cap drilling, as you see. High mud weight 2 ppg, more than mud weight is pumped regularly from annulus every 30 minutes. Hard plugs, sometimes we are making hard plugs like cement, bentonite with cement, gersonite with cement or whatever. New solutions for loss of circulation, like something is called Forma A plug, which is depending on the cross-linking polymers to make cross-linking between the particles, and so it can prevent the losses and cure the losses. Like the most important, the Forma A products, yeah, okay. Forma A products is the most common, yeah, okay. It's cross-linking, the linking between two independent polymers change by grouping that spans or links two chains together, as you see this one and this one. So the cross-linking between both of them will result in material that can plug the pores in the loss of circulation. Uh, Finally, today we will talk in brief about well control, but for sure we will talk in details inshallah in the course itself. Yani in the course itself, we will talk about everything in detail. Well control today, we will talk about what is the leak-off test. Actually, the most important thing in the well control from my side is to understand the well control itself, so it can help you to pass the test for any IEDC or IWCF. and you have to know exactly what is the meaning by MASP, maximum allowable annular surface pressure. But how can I get the MASP? What is the leak of test? Leak of test, actually it is done through leak of test, does involve the actual fracturing of the formation after drilling through the casing show and cement. Small section, typically 15 feet of new hole is drilled. The well is shot in and mud pumped at a constant rate into the well bore, so you can increase the pressure slowly in gradients and in increment one by one, one by one until it start to leak. Then once it start to leak, خلاص, you can stop. This is the fracture uh, pressure for you. So you can at this point take it as a leak of test. Okay. From the leak of test, you can get the maximum allowable mud weight. يعني, okay, the maximum allowable mud weight you can and also you can use. يعني, okay, this is the maximum allowable mud weight you can use, and from it you can get the maximum allowable annular surface pressure during the killing operation you can get. We will talk here about the bottom hole pressure and its effect. What is the bottom hole pressure? What is its effect? Yeah, by the way, why we should keep the bottom hole pressure constant all the time during kill the well. During kill the well, why we should keep the bottom hole pressure all the time constant? Yeah. Why? Because this is very important to avoid any extra pressure in the hole. Uh, Gas cut in the mud during the drilling. The increase in gas percentage in the mud may lead to decrease in hydrostatic pressure, so kick occurs. And from 2 days ago, there was gas cut in the mud leads to gas influx. Then after this, all the rig is blown out. This happened in Russia. This happened actually in Russia 2 days ago. So this is very important to know the gas cut and mud. This is very important. What are the sources? Number one, the connection gases. We will talk about the connection gases. We will talk about the background gases. We will talk about also the drill gases and each one how to deal with them, by the way. Trip gases during a trip. So we will talk about this. Abnormal pressure zones. What are the abnormal pressure zones? Like artesian well. When, for example, here we have in Egypt something is called the منخفض القطارة. Okay, القطارة depression, where you see here, for example, this is the surface of the sea surface, the sea level, and this is the land. So this is artesian well. Here you have artesian well. It's connected together, by the way. So the pressure here is much more than that for the rig. Yeah. For example, here, as you see here, the datum. If I am calculating, it should be only this, but actually it is affected by this. So it can lead to abnormal zone, and it should be taken. You should take care during dealing with this situation to avoid any well control issue. Gas cap, gas cap also is abnormal zone. Abnormal pressure zones like faults, like sand lenses, like shale under compaction, salt domes, charged zones, for example, like drilling in water wells, يعني during water injection well zone, يعني water injection zone. So sometimes it is charged zones. يعني, okay. What are the pressure indications or warning signs you are about to take kick? What about it? Change in mud background, drilling break, improper hole fill, pump pressure decrease and pump strokes increase, decrease in circulating drill pipe pressure, increase in stroke per minute, increase in drill string torque and drag, size and shape of the cuttings changes, salinity changes. Okay, salinity changes. and shale density decrease, and all these are the warning signs we will talk about. Also, we will talk about the shallow gases because shallow gases sometimes you can't take care of them, so it leads to blowout or problems. يعني, by the way, when you penetrate it. Okay. Uh, we will talk about shutting procedure, hard shutting, short, soft shutting, during drilling, during tripping. Okay. And so soft shutting during drilling, hard shutting during drilling, soft shutting while tripping, and hard while tripping. Okay, vertical kill sheet. We will talk about the vertical kill sheet and how to solve it properly. Okay. We will talk about the killing method and the most important to keep bottom hole pressure constant, like driller method, weight and weight, and concurrent method, and wave volumetric method. Here, as you see, the driller method is called two circulation method because you are circulating with the first one to get rid of the kick and then bump the kill mud weight in the string while keeping the casing constant until reach to the bit and change to keep the drill pipe constant. Yeah. This is the most important thing in driller method, as I will talk to you, is what is the pressure that should be constant to keep the bottom hole pressure constant during the kill operation. For example, as you see here, after you got a kick, so you shut in the well. Shut in the well, you have here the drill pipe has 520 psi, and here casing has 820 psi. So if I need to use the driller method because it's easy, by the way, it's circulation. So I should start circulation until I get this kick out. So here, and if I see the annulus, I don't have homogeneous fluid. I have kick and I have mud, so they are not homogeneous. But the drill pipe is homogeneous, right? So I have to start up the pump while keeping the casing constant until I reach to the kill rate. Then I will continue pumping in the drill pipe, keeping the drill pipe pressure constant by keeping the drill pipe pressure here constant by the ICP until I get all the influx out. خلاص, this is the first circulation. Okay, so the first circulation start up the pump from 0 to kill rate by holding the casing pressure constant, as you see here. Now this is the ICP. So when the pressure reaches to the 24 stroke per minute, look at the drill pipe pressure, which is ICP. So holds it constant at this value for bottom up, for one bottom up until the casing this gas comes out. You will keep this pressure constant until get this out. Okay. Uh, Here, after the bottom up, shut down the pump and look at the pressures. They should be both are the same. Should be shutting casing pressure equal shutting drill pipe pressure equals the beginning pressure for the shutting drill pipe pressure. خلاص? Should be both are the same. In case shutting casing pressure more than shutting drill pipe pressure, which means you got second kick during circulation. Okay. So here now you have these pressures are the same. So you can start pumping the kill mud in the drill pipe here, as you see in the drill pipe. So the drill pipe now don't have homogeneous fluid, but the casing has homogeneous. So I will keep the casing constant during the killing in the second circulation. Right? So this is very important to know. When up to speed, maintain casing pressure constant is at the bit. And then once the bit here, once the kick mud is at the bit, I have now, this is homogeneous, but it will come out, the kill mud will come out, so both of them is not homogeneous. So I will switch to keep it here and keep the mud weight with the FCB until I finish killing the well, and both of them will be the mud in equals the mud out. Okay, we will talk about this in details here. Second one is the weight and weight. Weight and weight actually by preparing the kill sheet, you have here pressure drop. يعني you have here pressure drop from ICB or schedule يعني from ICB to FCB step by step because you are pumping kill mud from scratch. So from the beginning يعني. So you have here only one circulation time. Weight and weight, you have to start up the pump, also keeping holding casing pressure constant. When it reaches to the when the kill mud reaches to the rotary table, zero stroke. Okay. Here, once up to the speed, the ICB the drill pipe pressure should be in the ICB and it should be scheduled as per the steps in the strokes until reach to the final FCB. FCB, when I reach to it, the mud should be at the bit. The mud should be at the bit. So once the mud at the bit here, okay, I will keep the drill pipe constant by the FCB. Once the kill mud at the bit, hold the drill pipe constant with the FCB. So here final circulating pressure يعني. So all the mud after this continue until get rid of this kick out and kill the well, as you see here. Yeah. Okay. This were the two killing methods. We will also talk about some blowout preventer systems like the BOB stack. What is the difference between annular and pipe ram and shear ram and everything? What is the choke, the emergency, everything. Yeah, we will talk about the pipe as a BOB. Yeah, okay. Annular BOB, we will talk about it in details. We will talk about the pipe rams and the difference between them, pipe ram, blind shear, variable, and about the BOB test, why it is every 21 days, and also the acceptance test for the pre-spot every for RAM and for annular periodic test, and also the function test. We will talk about here the COM unit and the remote control unit in details and why sometimes here we make the function, but actually the function cannot be implemented through the BOB itself. And what are the problems may encounter? We will talk about the difference between the inside IBOB and the full opening safety valve and what is the difference between both of them and what is the usage for them. Mud gas separator, we already talked in the mud section or on the separation solid control, but here we will talk about it from the well control point of view about keeping the back pressure on the choke also, why I should make the back pressure very low to keep the gases all the time out from the mud gas separator. We will talk about the choke panel here and how to adjust this choke panel how to adjust this choke panel to keep all the time back pressure during killing the well. Actually, this was very small and brief about the advanced mud school. Actually, I hope I could deliver some of what we will take in the course. The course will have a lot of details about all these notes that we have talking today, and more than that, more than this information. Yani. So I hope to see all of you in this course, inshallah, later. Yeah. This is from my side, Mr. Adil. For the guys, if they need. Okay, Mr.
Thank
Adil, if you need
you,
to
Abdulaziz, for
say.
this fruitful session. We will have just 2 minutes break, and then we will be able to receive the attendees' questions through the chat box. Thank you.
Thank you very much.
about the presentation, I will ask Engineer Abdulaziz to share it with me so that I could share it with you on the group.
Okay, no problem. No problem.
Okay, now it's time to receive your questions. Please, if you have any question, type it in the chat or just raise your hand and I will enable the mic for you. Okay, so we have the first question uh, from Engineer Natij. Could you talk about nanotechnology and smart drilling fluids in real situations?
Where is the question?
In the chat.
Shit, okay, what is the recommended drilling fluids for high BIT, right?
There is a question for it.
Okay, let me check. Okay, no problem. Okay. Could you talk about nanotechnology and the smart drilling fluids in the real situation?
Yes.
Actually, we will talk in the course about the high performance mud, which will include some about nanotechnology and also about and about these types. Yeah, actually, it will be through the high performance mud. We have some about nanotechnology of them. So we will talk inshallah in the course. What is the recommended drilling fluid for high B, high T wells? Actually, for high B, high T wells, depending on the temperature, depending on the conditions, we are adding chemicals that can withstand this high temperature. For example, if my temperature is 300, I can use some systems like FlowPro or other types يعني, which can withstand this temperature. Also, I am adding some things called polymer stabilizer or polymer stabilization stabilizer يعني, like for example PTS 200, which can help me to keep the parameters of the fluid constant. Yeah. Okay. What is the best way to keep reservoir pressure constant? To keep reservoir pressure constant, يعني actually to keep it constant, يعني there is no kick. To keep over balance, to keep the during drilling, to keep drilling, to keep the hydrostatic pressure overbalanced by 200, 300, for example. يعني. So you will keep the reservoir without any issue. Without any issue. Nanofluids could be used in the replacement of oil-based mud, depending on in the situation actually. I will check about the nanotechnology fluids so we can check about them here. What abbreviation of FBR in mud report means? Actually, I didn't see FBR in mud report. يعني. So I don't know actually. I don't know what is the FBR by the way. Because I didn't see in mud report yet.
So I have a private question
Go ahead.
about the nanofluids. What is يعني what is the reasons of this situation? You said that it depends on the situation. What are the situation that nanofluids could be a replacement for oil-based mud?
This is for me, yeah.
Yes.
Actually, nanofluids يعني or high performance mud and nanofluids. Actually, this is new technology. To be honest about it, yeah. I didn't use it in replacement of oil-based mud, but my friends say sometimes they use it as a new technology. So let me check for them or for it well, and in case we have something to replace for the oil-based mud, we can do. If its parameters can make good inhibition or whatever, we can go through. Otherwise there is no usage because this is very expensive chemicals, by the way. This nano one, by the way. But actually, it's like the high performance mod. يعني nano even has high performance mod also. Okay, so it's the same.
Okay, thank you.
Thank you very much.
Engineer Muhammad followed up this question. He said that in the comment section it's written that they have added FVR.
Really? Again?
In the comment section it's written that they have added FBR in the mod report.
Actually, I need the med report so I can exactly see what's the meaning of FBR because I didn't see it before. How mud test influence the pressure? Sorry. FBR here in the comment section, it's written that they have added FBR. Okay, which report يعني MI Halliburton or Baral EMIC يعني I need to know, I need the report so I can read it. But to give me something in brief, I don't know actually. FBR, I don't know. In COMI system, what means exactly for the pressure minimum or equal to the closing pressure? Minimum and equal to the closing pressure. In COMI system, what mean exactly for the pressure minimum? Yes, minimum pressure, for example, in the community. We are making something is called the hydromatic switch, يعني pneumatics, sorry, the electric switch and the hydropneumatic switch. Hydropneumatic switch, for example, air-operated hydropneumatic switch. Actually, this is to keep the pump for air pump to start by, for example, less than 10% from the pressure. For example, if I have 3,000 in the community, the air pump should start automatically at 2,700 because if there is something bleeding, you will not know if it is not compensating. Yeah. And for electric, it should be less than 100 psi. So this 2,700, and for electric 2,900. Okay. Here. At which level of temperature and pressure does we use in laboratory? What's this? At which level of temperature and pressure does we use in the laboratory? What we use? Nano. Okay, let me check. Actually, I don't know, but let me check. Okay. Can you speak about minimum and maximum horizontal stress? Actually, we will talk about this minimum and maximum stress in the rock mechanics. This rock mechanics, يعني it will be part of the drilling mainly, and then sometimes about the stock to know about the stresses. But يعني, we will talk about in brief in the course. Actually, we will not take in deep details here. Okay, but this is important. Here, how mud test influences the pressure and temperature. How mud test influence for pressure and temperature. I think you mean how mud test is influenced by temperature and pressure. Yeah. Sure, because you have so if you have API test and you have high P high T test, so this is different. The temperature itself affects on the properties of the chemicals and everything. So it's for sure the result of the test will be different. Anyway, guys, this is good questions. Uh, Actually, I was very happy about this discussion, about this discussion. And inshallah, I hope to see all of you in the session, inshallah, or in the course starting from next Saturday, inshallah. Mr. Adil, we have any other issue?
We just have one more last question.
What test should be done for the committee test system? It's called drawdown test. Drawdown test, you have to shut off any power and to check for the 3000 to be sure that it can make all the functions of the BOB and keep at least 200 psi above the pre-charged pressure for nitrogen. And for example, if it is 3000 psi, it should be enough to close and open the annular, close and open the rams, close and open the HCR, and once you finish, it should be at least 1200 because we need 200 more than the pre-charged nitrogen, which is 1000. Thank
Okay,
you very much for this session. Okay.
thank you, Engineer Abdulaziz, for this fruitful session, and thank you all for attending. See you soon, inshallah, in the next course that will be presented by the same instructor of today's webinar, Engineer Abdulaziz, titled IEDC Advanced Mod School. Thank you, and see you soon, inshallah, in our next webinars. Thank you.
Thank you, Mr. Adil. Thank you, all the group. See you later, inshallah. By the way, Mr. Adil, when will be the course? Saturday or Sunday?
Saturday.
Saturday.
Yeah.
Okay, at 7, huh?
Yes.
Okay, thank you very much, Mr. Adil. Thank you very much.
Thank you.